Welcome to Fiberstar Citri-Fi Emulsification Properties in Food Applications webinar. I want to thank you for attending this session and we appreciate your feedback. Before we start, I'd like to cover a few webinar service items. This webinar is muted to provide you the highest audio quality. This webinar is also recorded and it will be available to you after the 3 sessions have been broadcasted. There will be 3 poll questions during this webinar. These poll questions will be spread throughout the session and answers to these poll questions will be shared to keep you informed. You can ask questions at any time during the webinar. Please locate your question box, type directly into the box and push submit. These questions will be answered at the end of the session, and if you have additional questions, please contact your Fiberstar sales manager and we'll follow up with a response promptly. A survey will follow this webinar. Please take a moment to fill this out as this information will be used to improve future webinars. Now I'd like to introduce the webinar speaker team. The first speaker is me, Jennifer Stevens. I currently manage Fiberstar's marketing communication program, and for about 15 years I've researched in R&D, marketed, and sold functional water management ingredients such as starches, gums, and fibers to the human and pet food industries. Today I'll review market trends affecting the emulsifier category globally, which includes the regulatory updates, functionality advances, and clean label and environmental concerns. After reviewing the market conditions, I'll briefly review the Citri-Fi product line, which includes 100, 125, 200, and 300 series. Kurt Vilwak is our newest team member, who is the Director of Research and Development. Dr. Vilwak started out his career in hydrocolloids in '92 at Continental Colloids & Company, developing stable blends for large dairy companies. He returned to school to get his PhD from the Whistler Center for Carbohydrate Research at Purdue University. As part of his studies, he spent a year as a guest researcher at the University of Lund, Sweden, where he taught rheology. Upon graduation, Kurt worked as a starch chemist at Penford Food Ingredients before taking a job in Stockholm as a research coordinator for a large agricultural co-op. Prior to starting Fiberstar, Kurt worked for the consumer products companies H.G. Heinz and Keurig Green Mountain. Amanda Wagner is a food technologist at Fiberstar in River Falls, Wisconsin. Amanda has more than 3 years' experience working with Citri-Fi and food applications. She has a bachelor's degree in food science and technology with a concentration in food science from the University of Wisconsin-Stout. And finally, Nisha Zalesny joined Fiberstar in January of this year as a technical sales manager. Her educational background includes a Bachelor of Science in Food Science from Brigham Young University and an MBA from Cal State San Marcos. Nisha started her career at Calco working with alginate xanthan and gel and gum in beverages, dairy, salad dressings and sauces, and baking applications. Pectin, carrageenan, and carboxymethylcellulose were added to our hydrocolloid portfolio with the merger of Hercules and Calco. In addition to CP Calco, she worked in a small coffee company formulating ready-to-drink and dispensed coffee and tea beverages. Mrs. Zalesny's extensive experience and knowledge within hydrocolloids provides her the expertise in providing customers technical service and sales support. That being said, let's get started. This webinar is the first of several webinars in this emulsification series. There are a few university studies in progress that are generating more data and information around sensory, shelf stability, and performance. The science will be discussed further in the future webinars. Today we'll be covering the market and the Fiberstar Citri-Fi portfolio review. The technical review will cover Citri-Fi's emulsification properties within applications such as soups, sauces, dressings, beverages, ice cream, bakery products, bakery fillings, meats, and spray drying. This overview will be followed by a summary and a Q&A. Market trends affecting the emulsifier category vary around the world. Within the United States, there are a few key trends influencing the type of emulsifiers used in food applications. One popular trend prevalent in the United States, Canada, Europe, and other parts of the world is a clean label phenomena. Consumers are reading labels more than years before, which is influencing their decision process. Some consumers scout for products that contain ingredients that are familiar, found in the kitchen, and not chemical sounding. Other consumers are preferring shorter ingredient labels and simpler, transparent offerings. Another trend is using emulsifiers not derived from partially hydrogenated oils, or also known as PHOs. In 2015, FDA removed PHOs from the GRAS, or also known as the Generally Recognized as Safe list. This decision was driven by the correlation to negative health consequences such as heart disease. As a result, formulators have until 2018 to remove PHO ingredients from their food products, although need to petition the FDA to obtain permit for specific uses. Many emulsifiers such as mono and diglycerides and datum using PHO as sources. Therefore, this affects numerous food products such as baked goods, dairy products, ice cream, snacks, and confections. Another trend involves using ingredients free from genetically modified and/or bioengineered practices. Significant parts of the world naturally offer ingredients in food products without GMO. However, more developed countries like the United States are faced with pressures to limit or eliminate the use of GMO practices to preserve the natural crops. Several crops, including soy, are mostly genetically modified, therefore affecting the supply of emulsifiers such as soy lecithin. A growing but loyal consumer base in the United States and now in Europe is the vegetarian-vegan segment. In addition to this consumer segment, there has been an uptick in demand for plant-based proteins and ingredients over animal-based sources. Emulsifiers originating from animal sources like egg and dairy are being replaced by plant-based versions such as soy and sunflower lecithin. Another green trend is corporate sustainability. Watch groups and associations in the United States closely monitor certain ingredients such as palm oil, which is sourced for mono and diglycerides. Palm oil suppliers work closely at the round table on sustainable palm oil in efforts to develop and implement global standards. Finally, the most exciting market trend involves suppliers offering newer and better technologies. For emulsifiers, this can mean increased oil loading capacity, reduced viscosity, and increased stability for flavors and colors used in beverages. This could lead to a potential cost savings, which is a global demand all around. In Europe, there's still a push to remove E-number ingredients. This is driven by the need for more natural food products. Depending on the food product listed, formulators are tasked to remove monodiglycerides, chemical emulsifiers, modified starches, allergens, and E-number ingredients such as CMC, carrageenans, and gums. Europe is also experiencing an increase in demand for vegan and vegetarian products. Though formulators are turning to modified starches to provide emulsification, these starches contribute empty calories for some of the fiber-based emulsifiers in the market. There continues to be an interest in free-from foods, and these foods are produced without using milk, gluten, egg, soy, and other common allergens. As a result, product developers are seeking out alternatives to milk and egg-based emulsifiers, which are typical workhorses. Specifically, the meat industry is exploring alternatives to soy and dairy emulsifiers that are typically used in meat emulsions. In Canada, mono and diglycerides chemical perception have formulators turning to soy and sunflower lecithin. In Central and South America, cost is the biggest driver when deciding to use certain emulsifiers. New emulsification technology to reduce costs and improve functionality with food product is driving the category. In Asia Pacific, the emulsifier category is growing due to the food demand in emerging countries. In some countries, busy lifestyles are driving the need for convenience foods where emulsifiers are used. In other regions, obesity has caught the industry. As a result, food manufacturers are creating reduced calorie and fat foods by using emulsifiers as one of their formulating tools. In some regions, regulatory organizations are revamping their safety standards, which affect the ingredient's acceptability as safe in its intended use. And finally, in some countries, companies are shifting their interest to clean label formulating, which affects what type of emulsifiers are deemed acceptable. Citri-Fi, a natural citrus fiber, provides the emulsification properties due to its high surface area. Citri-Fi can be labeled as citrus flower, dried citrus pulp, citrus fiber, which resonate well in the clean label markets. This natural fiber has no E-number. The Citri-Fi is allergen-free, compliant with the National Organic Program, and is non-GMO. Because this fiber is derived from citrus pulp, Citri-Fi is plant-based, which contains both insoluble and soluble fiber. Citri-Fi is produced using sustainable practices in sourcing, production, and final incorporation. Citri-Fi base material and manufacturing is in U.S. and not in geopolitical unstable environments like some other ingredients. And finally, in addition to the emulsification stabilization properties, This natural citrus fiber provides additional functionalities depending on the food product, including moisture retention, clouding, mouthfeel, stabilization, some viscosity, and reduced syneresis. Now that I've provided some of the Citri-Fi's high-level proposition, let's review the Citri-Fi product line. What creates Citri-Fi's unique functional benefits? The Citri-Fi 100 product line is derived from raw orange pulp, generated from the orange juicing process. The natural fiber cell structure is mechanically processed using patented technology to create the extended surface area, which you can see in the far right. Due to the patented process, the soluble and insoluble fiber, protein, and lipids stay intact, providing the high water holding capacity, natural emulsification, and gelling properties. Since the Citri-Fi 100 fiber line is produced from byproduct created from the juicing process, the proprietary technology supports a sustainable story. Fiberstar offers 10 product types differentiated by the composition and particle size. As you can see, these products can be used in various food products including meats, bakery, beverages, sauces, dressings, dairy, and other food products. This matrix outlines the different product lines and their uses across various applications. Depending on the food application and Citri-Fi product line, this natural fiber provides emulsification properties in almost all the applications listed. The technical team will provide you a more detailed review on how Citri-Fi works in various applications. We've come to our first poll question of today, so I'm going to go ahead and launch the poll. The question is, if you're currently looking for clean label emulsifiers, which applications are you working on that apply? Are you working on bakery, dressing and sauces, beverages, dairy, or plating applications involving flavors, spices, or bioactives such as omega-3 oils? And you can choose more than one. Well, it looks like we have almost everyone voted. I'm going to give it a couple more seconds. I'm going to go ahead and close the poll. And let's take a look at the results. So as you can see here, we have several people working on the bakery and dressing and sauces and dairy applications and looking for emulsifiers, whether it's clean. I'm going to go ahead and hide this and return back to the presentation. So now that we have just finished the first poll question, I'd like to move on to the technical review. Brock, thanks for joining us today. I'm going to hand this off to you.
Okay. Thank you, Jenny. Welcome to everyone. We're excited to present the information on this webinar. We're continuing to develop new information thanks to other research studies underway. So this webinar is part of a series that we started because of Citri-Fi's interest in the emulsification properties. After I discuss some of the technical attributes of our product to explain how and why Citri-Fi functions, Amanda is going to cover many of the different applications before I finish up with a few spray drying slides. Citri-Fi has natural emulsification properties due to its innate hydrophobic and hydrophilic attributes coming from its natural composition. This results in both water and fat binding properties in many different food, beverage, and personal care applications. Citri-Fi has the ability to absorb large amounts of water due to its amorphous fiber structure and adds to the mouthfeel and overall texture of the product. This added texture is especially desired in meat, beverage, and dairy products. And as Jenny covered in the beginning of the webinar, various grind sizes of Citri-Fi are available, in addition to having product options coming from pulp or peel of the orange. This helps aid in the manipulation of the texture and viscosity that is preferable in each application. The label declaration is also a big advantage of Citri-Fi in the formula, especially when using the 100 or 125 series, where citrus fiber or citrus flower are typically the ingredient list. This can vary on your countries and the regulations specific to each application. Some advantages of using Citri-Fi include the ease of incorporation. For example, it can be added to dry ingredients that are already in the formula, or it can be added to liquid oil followed by the addition of water. Or a third recommendation is to just add shear, to include shear with the liquid ingredients to break up any lumps when the Citri-Fi is added. Any one of these mixing procedures will help, but the main functionality comes once the product is hydrated, and it can be swollen to absorb both the water and the oil. Citri-Fi is also stable and resistant to a wide range of pH and temperature conditions, and does not require heat or other additives to be activated. In this section, we'll do a brief review of emulsifiers. So what are emulsifiers? Emulsifiers act both with the hydrophobic and hydrophilic phases of a system to make an otherwise unstable heterogeneous mixture of two phases, like oil and water, homogeneous and stable. In this picture on the right, 5 grams of Citri-Fi 140 is used to emulsify 15 grams of oil and 50 grams of water. This is actually a common demonstration we do with many customers and is relatively easy and does not require shear. Citri-Fi is somewhat complex in its molecular structure because of the natural composition. It's not purified, but yet we do open the cell structure of the natural pulp cells used as our raw material to form this open, porous, high surface area network that binds both water and oil. The product contains both soluble and insoluble fiber, along with protein, to help bind water and oil in one particle. This water binding fraction of Citri-Fi comes primarily from the soluble fiber, especially pectin, that's loosely woven into the insoluble fiber matrix. And the cellulose fiber forms an insoluble scaffold within the particle, and there's many interstitial spaces for which oil can be bound. Unlike many traditional emulsifiers, which need a high shear mill to form an emulsion, it takes relatively little shear to get the oils to absorb to these spaces. And there is additional 8% protein in the Citri-Fi that also helps with the emulsification properties. The hydrophobic regions of the protein are attracted to the surface of the oil droplets, and also the protein interacts with the protein and the pectin to help stabilize oil. In this picture, you can see how through our natural processing, we open the cell structure so that the oil has easy access to the cellulose microfibrils. In this image, which is done at the University of Minnesota, using SEM, 3,000 times magnification images were taken after oil, water, and Citri-Fi were sheared together, and you can note how the oil, as outlined in the small droplets here, coat the surface of the fiber and remain bound to the fiber structures. To have a point of comparison for the various types of Citri-Fi, as well as a few other emulsifiers, we conducted this study whereby oil, water, and the shown stabilizers were sheared in a blender and centrifuged at 1,000 RPM for 10 minutes. After the centrifuging, we were able to determine if the emulsion was stable by how much oil was separated after centrifuging. This helped determine an oil binding capacity, which we called the Emulsion Stabilizing Index. A detailed procedure for the comparisons can be provided upon request, but the data is shown here in this chart, where Citri-Fi 140 holds approximately 6 times its weight in oil when hydrated and emulsified, compared to the 125 and 40 that held approximately 7 times its weight in oil. The 100 FG held approximately 8 times its weight in oil, compared to oat fiber at 1 times its weight, lecithin at 3 times its weight, and monodiglyceride, which was actually fully heated to melt and be blended, followed by shearing, held 4.5 times its weight. Note that these results are not expected to carry over into all applications, but do serve as a starting point as we study more food and beverages, which Amanda is going to cover more in the next section. And with that, we'll turn it over to you, Amanda.
Thank you, Brock. Today I will be covering soups and sauces, dressings, beverages, ice cream, bakery products and their fillings, meat applications, and spray drying throughout the webinar. This slide shows how Citri-Fi 140 is able to emulsify both water and oil phases in this soup application for a dual role of improved appearance and a mouthfeel of the final product. In the control sample, where no Citri-Fi is being used, oil droplets are assembling on top of the soup. The black arrow in the photograph is pointing to these droplets. Citri-Fi can also be used in dressings to replace eggs, oil, or other emulsifying ingredients due to its emulsification properties. In this dressing formulation, Citri-Fi 140 and 340 are used to replace 25% of the egg content with water. The recommended ratios in each formulation, which is shown in the title, displays parts of Citri-Fi, 2 parts of water to replace egg. In this slide, Citri-Fi 340 is used to replace 25% of the fat content with water. Note that the ratios may change and are dependent on your own formulation. This example shows fiber to water recommendations ranging from 1 to 9 to 1 to 12, which would be a great starting point for your own formulation. In this slide, Citri-Fi 100 mg, along with some formulation adjustments, is used to replace modified starch. This concept was applied to the dressings in the picture. In the picture, from left to right, we have a honey mustard dressing, green tea dressing, mayonnaise with half the fat, coleslaw, and an olive oil garlic dressing. For this and other applications, to incorporate Citri-Fi, mix into the formula's dry ingredients or into the fat oil phase, followed by water addition. Because Citri-Fi contains insoluble fiber, an appealing and natural clouding effect can be noted at a low inclusion rate for juice applications. In the photo, Citri-Fi 140, plated with the tangerine oil, is providing various levels of opacity from 0.001% to 0.15% in a water solution. An added benefit of using Citri-Fi here is for its mouthfeel attributes, in providing a natural pulpy texture rather than a gummy texture. It is important to note that by itself, at such a low level, Citri-Fi will separate out of solution. So for shelf stability, Citri-Fi is often paired with gel and gum, other stabilizing, suspending agent. In this slide, 0.03% gel gum is used as a suspending agent, and stabilizer along with 0.3% Citri-Fi 140 for its emulsification properties. At the University of Minnesota, in their pilot plant, a full-scale trial was conducted to show how Citri-Fi 140 and gel gum can be used together to produce a stable Mocha beverage over time. The sample in the picture has been held for 4 months and is still stable. One of the more recent applications we have discovered of Citri-Fi is plating. Plating refers to mixing dry ingredients with liquid oils to form a dry flowable powder. Because Citri-Fi has such a high surface area, it is very effective at carrying oils. You can see from the photomicrographs of Citri-Fi at 100 times and 1,000 times magnification that there are many valleys and peaks on the surface of the fiber. Based on testing of several types of liquid oils, typical oils can be loaded on Citri-Fi at levels of 15 to 25% with no noticeable difference in dryness and flowability properties. This method for dry plating is extremely simple, where oils can either be added in gradually or sprayed onto the fiber structure, followed by mixing and screening to make a dry flowable powder. Some of the added benefits of using Citri-Fi as a carrier are that no additional emulsifiers are needed, since Citri-Fi can function as an emulsifier in many applications, and many of the commonly applied benefits of Citri-Fi can be carried into the final application, depending on the final usage levels. The measurement of powder flowability is a major concern for most industrial processes that deal with the handling of bulk solids. Thus, we measured flowability based on both sensory and analytical methods at the University of Minnesota to quantify flowability of Citri-Fi and Maltodextrin plated with liquid oils. As we can see from the data in this slide, oils can be plated on Citri-Fi at levels of 5 to 6 times more than Maltodextrin, while maintaining a flowable dry powder. For instance, Citri-Fi 140 can be plated at oil levels of 25%, whereas Maltodextrin has only the ability to be plated at 4% to maintain this dry flowable powder. This shows that Citri-Fi has 6 times more carrying capacity when compared to Maltodextrin. In this example, I am using Citri-Fi 140 as a carrier for lemon oil, which is often used in beverages, but also has many other applications. Because Citri-Fi is able to hold onto the oil and still remain a free-flowing powder, the dry plating process for lemon oil and Citri-Fi is the same as outlined in the prior plating slide. The final plated powder is well suited for not only a carrier, but as a way to improve mouthfeel and texture in the final beverage application. As an example, one of the interesting applications for this plated lemon oil is a powdered lemonade beverage. This is a neat formulation to show customers because it is simple and it demonstrates the many attributes of Citri-Fi to A, act as a carrier for that plated lemon oil, B, provide clouding, and C, emulsify the oil. You can also easily make a comparison of this formulation shown here versus one without Citri-Fi to show a clear difference of a beverage with layer of oil separation, which would not look like a lemonade if Citri-Fi is not used. It is a neat demo to show how Citri-Fi provides many different attributes when used as a carrier, emulsifier, and clouding agent. At the University of Wisconsin, in their dairy pilot plant, a full-scale ice cream trial was run with an objective to determine if Citri-Fi could replace a proprietary stabilizer emulsifier blend containing microcrystalline cellulose, carboxymethylcellulose, and carrageenan. This trial was successful with both Citri-Fi 140 and Citri-Fi 120 at 0.8%. Initially, texture was very similar to the stabilizer emulsifier blend in the reference formulation, but however, after a year of hold time, the texture of this reference became very gritty due to the amount of large ice crystals, and the samples with Citri-Fi maintained that smooth texture. This is shown in the next slide. This graph shows the sensory evaluation that was conducted after 1 year of storage. The blue line represents the stabilizer emulsifier blend. The orange line represents Citri-Fi 140, and the gray line represents Citri-Fi 120. You can see that the sample with the stabilizer emulsifier blend scored very high in grittiness, while the samples with Citri-Fi had a much smoother texture. This led the preference score of the samples with Citri-Fi to be much higher than the reference sample. This chart shows how Citri-Fi 140 and 120 slowed the melt rate of ice cream as compared to the stabilizer emulsifier blends, where again the blue line represents the blend, which melts faster compared to Citri-Fi 140 and Citri-Fi 120. Citri-Fi can also be used in a variety of bakery applications for egg replacement and moisture retention capabilities. Key benefits for baked good manufacturers include ingredient cost reduction, moisture retention, improved structure, natural emulsification stabilization, improved label and nutritional declaration, maintain quality over shelf life, and can be used in gluten-free bakery items. Typical recommendations include replacing up to 20% of eggs with the 200 FG product at a 1:14 ratio, or up to 15% of eggs with 125 FG, but this can be dependent on your own formulation. Here's an example of how Citri-Fi 200 FG and Citri-Fi 125 FG can be used in a muffin formulation. Citri-Fi was incorporated by pre-mixing directly into other dry ingredients. Also note that the formulation total does not change. The total weight of the egg that was removed was replaced with water and Citri-Fi. The recommended ratios in the title displays parts of Citri-Fi, 2 parts of water to replace egg. The graph displays moisture retention in these muffins over a 14-day period. Note that the sample without Citri-Fi loses more moisture throughout the baking process and during shelf life. This is a sensory evaluation of the muffins from the previous formulation, showing an increase in preference and texture when using either the 200 FG product, indicated by the purple line, or 125 FG, indicated by the green line, for egg reduction. In bakery fillings, Citri-Fi can aid in emulsification, help bind water, reduce blowout during the baking process, and reduce ice crystallization if your product is frozen. Other than fruit fillings, as shown in the photographs, Citri-Fi can also be used in cream and custard formulations to provide heat and emulsion stability. Citri-Fi can be used in marinades to help emulsify the marinade and improve marinade adhesion onto the substrate, in this case chicken. Citri-Fi also provides a greater tolerance when cooking meat products due to its ability to bind juices native to a meat product. In the formula, Citri-Fi 300 FG is used. However, the Citri-Fi 100 and 200 series have also been used commercially in the same type of application. This is a photograph of the marinade formulation from the previous slide. On the left, you can see that the control marinade is separating and isn't adhering to the chicken. On the right, you can see that the marinade with Citri-Fi is emulsified and is adhering to the chicken, resulting in an increase in yield, improved juicy texture, and contributes to a clean label, having no E number. This is an industry example of using Citri-Fi in a barbecue chicken marinade in Australia. You can see the label declaration on the right as citrus fiber. I will now be handing the presentation back over to Jenny for our second poll question today.
Thank you, Amanda, for the extensive applications overview. I'm going to go ahead and submit our second poll question for today. The poll question is, what are the most important attributes when choosing emulsifiers? You can choose more than one answer. Is it label declaration, non-GMO, non-bioengineered, vegetable-based, non-sourced from partially hydrogenated oil, or other? Well, it looks like almost everyone has voted, so I'm going to give it a couple more seconds and close the vote. Okay, so I'm going to go ahead and close the poll. Let's take a look at the results. As you can see here, one of the two leading attributes that people are looking for in emulsification or emulsifiers is the label declaration and the non-GMO, followed shortly by the no PHOs. Thank you for participating in this poll. We're going to continue on with the next section, so I'm going to hand this off to Brock, who will discuss spray drying.
Okay, thanks Jenny. Go to the next slide. One of the newer areas that we've developed the past couple months is how Citri-Fi can perform as an emulsifier in spray drying applications. While we didn't do a specific spray drying area application, we did start with a generic formulation that's applicable to a wide area of spray dried products before we go deeper into the specific application targets. Here's the basic process for spray drying that we used in our testing, which is typical of a commercial production process. First, the ingredients are mixed and hydrated in a mixing tank before being homogenized and pumped into a feed tank. In the feed tank, it's critical that the oils do not separate out of solution or they cause problems with inconsistencies and many other problems in the spray dryer, so emulsifiers are needed. After the feed tank, the solution is spray dried, collected out of the airstream using cyclones and/or baghouses. The formulations we used for the spray dryer are shown in the table here. To maintain the stable emulsion, we used 7% gum-arabic to suspend a solution that contained approximately 6% oil. Maltodextrin was used as the primary bulking agent and the carrier in all of these trials. Citri-Fi alone will become too thick if levels over 1% are used and will cause issues with the dryer, so we did not attempt the higher concentrations in these trials, but did find Citri-Fi work very effective as an emulsifier at these low concentrations, rather than trying to attain any higher concentration levels. In the test, we replaced gum-arabic using Citri-Fi 140 at 0.6%. The viscosity of the sample was low, very similar to the gum-arabic test, and the solution remained stable without oil separation prior to drying. Once the solutions were mixed, they were homogenized, the oil particle size was measured, and they were spray dried using a Buki lab spray dryer operating at 190 to 220 degrees Celsius with a 100 degree Celsius outlet temperature. Here's a photo of the Buki lab spray dryer that we used as shown on the left. The dryer chamber, cyclone, and collection chamber were all glass. And on the right is the Fiberstar particle size analyzer we used for measurement of the solution particle size before, drying, and after rehydration. It was important to note that the feed solutions, as shown here in the upper right-hand part of the photo, where the arrow is pointing, was held for a period of time, over an hour, in both the control and the test, but they were stable without any oil separation, despite the feed solutions containing approximately 6% oil. The results from the particle size measurements of the feed solutions are shown here in this comparison slide. The gum-arabic test, as shown on the left, had an average particle size of 1.6 microns, but notice that there's two separate peaks with a wider distribution compared to the Citri-Fi test on the right, which had an average particle size of 6 microns and only one peak. We made several trials and measured the particle size, but the test with the 0.6% concentration had the smallest distribution. As you can imagine, homogenization was critical to attain the desired particle size in the most stable solutions of the water and oil. The results from the testing showed that the test with gum-arabic worked good, as expected, to maintain a stable emulsion, and it functioned well in the spray dryer. Additionally, the test with the 0.6% 140 worked very well in the spray dryer as well, and dried just as good or better compared to the gum-arabic with the closest particle size match. When we tested at Citri-Fi levels above 1%, we saw a large increase in viscosity, and the feed solution was not easily pumped through the system. In summary, from these trials we found that Citri-Fi and spray drying worked well at 1% or less as a way to replace emulsifiers such as gum-arabic, which is what we tested against in these trials. We also learned that maltodextrin is an effective carrier in spray drying because we were able to obtain solutions close to 50% solids, which is much more concentrated than we'd be able to do with Citri-Fi when it's hydrated, because it will generate high viscosity. In these trials, the maximum pre-dried solids content in the spray-dried solution was 1%. In our test, we used 0.6%, but the oil levels that we were able to attain was still, based on a dry solids basis, approximately 20%. And if you remember from the previous plating slides that Amanda covered, we were able to attain 20% oil loading levels by dry plating as well, without any spray drying involved. And this is a very simple procedure. This opens up the opportunity to plate oils on spray drying in certain applications where encapsulation from the spray dryer is not needed. Since dry plating doesn't truly encapsulate like spray drying, there are applications where dry plating is an option because it's simpler to use and the encapsulation is not always necessary in each application. To help simplify and break this down, we put together a chart showing the differences of spray drying versus dry plating. With both methods, similar oil loading levels of 20 to 25% can be attained to still maintain dry flowable powder. The difference being that with spray drying, maltodextrin and an emulsifier is needed for the added ingredients, but with plating, no other ingredient or emulsifier is needed. With spray drying, there is almost always a yield loss of 20 to 30%, whereas dry plating has much lower losses because no heat is involved and there's minimal air movement, which results in yield losses. And as for oxidation and shelf life testing, this is another important attribute that we are actually doing comparison trials as we speak. At the University of Minnesota, we plan to have data the end of January. This study that we're sponsoring will evaluate the oxidative stability of a citrus oil when dry plated onto Citri-Fi compared to another dry plating agent. While we don't have the cost comparison exact between spray drying and dry plating, generally we know that dry plating is a much simpler and less expensive process compared to spray drying with less capital and operating costs. And as a note of comparison, the dry plating information we showed earlier using maltodextrin as a carrier by dry plating results in a maximum of a 3 to 4% oil loading compared to the 25% levels that we can get with Citri-Fi with no needed emulsifiers. This results in a significant cost savings opportunity with a real clean label ingredient declaration. With that, we'll turn it over to Jenny.
Thanks, Brock, for covering the spray drying application. So I'm going to submit our last poll question for today. The question is, what functionalities in addition to emulsification do you look for when choosing emulsifiers? Once again, you can choose more than one answer. You're looking for stabilization, flavor dispersion, thickening, texturizing, or other functionalities. So it looks like almost everyone has voted. I'm going to get a couple more seconds. I'm going to go ahead and close the poll so we can take a look at the results. So it looks like one of the leading functionalities that product developers are looking for right now is the stabilization in addition to the emulsification. And after that, it looks like the thickening and texturizing are the second place winners in terms of functionality requirements. So thank you for participating in the poll. And we have covered a lot of information today, so I would like to recap a couple of the highlights. Depending on the geographic region, different market trends affect the emulsifiers category, such as clean label, price, functionality, GMO-free, animal-free, and sustainable sourcing. Because of Citri-Fi's natural composition of soluble and insoluble fiber and protein, this natural fiber provides a holistic mechanism in providing emulsification stabilization. The soluble fiber holds water to create some viscosity, while the insoluble fiber's surface area traps the oil and fat. And the protein, which binds the water and oil, forms stable emulsions, which is reinforced by pectin synergies. Citri-Fi provides emulsification benefits to a variety of food products, and there are several commercial products globally using this natural fiber for its emulsification properties, such as sauces, dressings, beverages, bakery, and meats. In addition to the food applications listed, spray drying is the newest area of development, as Citri-Fi can be used potentially to replace some expensive gums and other emulsifiers while providing oil loads in addition to other functionalities. This concludes today's session. I'd like to thank you once again for attending today's webinar. Please contact your Fiberstar sales manager if you have additional questions, and also please feel free to contact other team members if need be on this slide. We're going to move to the Q&A piece of the webinar, and we'll try to get through as many questions, and if we do end up running out of time before the questions are answered, a Fiberstar sales manager or technical service manager will follow up with you in regards to your inquiries. So I'm going to open the floor, and I'm going to take the first question. So the first question we have is, what grade and mesh size would you recommend for a BBQ sauce that has 0.2% of xanthan gum?
We actually have some barbecue sauce examples and applications. Typically, we would not use the coarse particle size. We would use one of the finer particle sizes. And if we're talking 100 series, which is what probably we'd use if we're not looking for viscosity, the 100 FG or the 100 M40 would be used. However, for a little more viscosity, we can also use 200 FG. Those are the products that we've used before, but it would be one of those grind sizes would be the most common. But we do have some more specifics we can share, but with detailed formulations and mixing procedures, but those would be, I guess, the ones to start with.
Okay, thanks, Brock. We have another question. What effect does shear have on Citri-Fi hydration and emulsion strength?
Well, shear will speed up the rate of hydration and result in ultimately a more stable emulsion by breaking up the oil droplets to finer particles. And we have actually quantified the extent of shear in our usage guide, where the shear helps to increase the hydration rate and ultimate final viscosity in the product. And we've seen in several trials where particle size of the oils is reduced and helping stability. So there's a benefit of shear typically, although it's not necessary. It does help stability over time. And we've never really seen that we can shear too much the Citri-Fi because of the insoluble matrix. It doesn't, and the soluble fiber don't get broken down with shear. So if it's an option, it can certainly assist in the functionality.
Okay, thank you. We have another question. In bakery products, is there a difference between Citri-Fi 125 FG and Citri-Fi 200 FG that was recommended in the webinar?
Hi, Jenny. I can take that one. So either can be used dependent on your formulation and objectives. The 125 is recommended if you're looking for a clean label, so no E number. And with the 200 FG, it has the guar in it, so you can replace a greater amount of egg with that product.
Okay, thank you, Amanda. Oh, go ahead, Brock.
Yeah, just one other consideration, and that's where we've seen in many different formulations for egg replacement specifically that 200 FG would bind approximately 14 times its weight. It varies, but 12, 11, or 12, 13, 14 times its weight in water compared to the 125 FG being closer to 20 to 22 times its weight in water, and resulting in some improved economics, just in lower cost, just because of the additional water binding capabilities with the 125.
Great. I have another question. Does Citri-Fi typically require additional hydrocolloids or co-emulsifiers to offer stable emulsions, or can it just be used without any helpers?
It's really dependent on the formulation and the viscosity of the product. If it's a low viscosity product, such as the beverages that we demonstrated in this webinar, there will be settling over time, and if it's a juice with natural pulp, that's somewhat expected and natural to have that settling, and in those applications other suspending agents aren't needed. But for applications where it's low viscosity and you want a stable solution for a long period of time, like in that Mocha example we showed 4 months, we have other clouding agents where it's been 6 months. In those applications where we want that long-term stability, yes, an additional suspending agent is necessary.
Okay. Actually, this was a two-part question. The second part of the question is, any incompatibilities that might be known when Citri-Fi is used along with other emulsifiers or stabilizers?
We haven't necessarily seen incompatibilities within a typical pH range anyway of 2 to 10 in a pretty broad range for pH conditions. However, the method of incorporation would be really important, that we try to get Citri-Fi into the formula early, either by mixing it with dry ingredients or some oil, followed shortly thereafter by water addition. And there can be competition for water if Citri-Fi is added after all the other ingredients and emulsifiers are added. So, I think that kind of answers that question.
Okay. And we have one more question, and that one is, how much oil can Citri-Fi bind or stabilize if there's no water added?
Well, if there's no water added, it's actually relatively low oil binding capacity compared to if water is added. Without water, the fiber doesn't swell, and there isn't nearly as much pores or surface area for oil to be entrapped and for the soluble fiber and protein to bind to the oil. But in a dry state, we see for the dry plating that typically 25% is the amount before it starts turning a little tacky. We have levels of up to 50% in certain applications, but that's where we're talking about 50% of the fiber weight in a dry application. But if water's added, as you saw in that emulsification index, we can get levels up to 6 or 7 times the weight for oil binding capacity. And that's with fully hydration and shearing. And so it kind of depends on the amount of water that's added, but definitely water makes a big difference in the oil binding capacity.
Okay, great. Well, I want to thank Brock and Amanda for handling all the Q&A, and this pretty much wraps up the Q&A part of the webinar. Please remember to fill out our survey, which will be available to you after this session, and the survey will help us improve future webinars for you. As mentioned, if you have additional questions, please contact us. We're happy to help get you what you need. With that, Fiberstar thanks you for attending the webinar, and please enjoy your weekend.